Hi, everyone. Good evening, good afternoon to everyone. Welcome to this 10 Analytics Masterclass series. My name is Mbalaji Baluba, and I'm the one that's going to be facilitating this session. So, hi, Dr. Askis, can you make my other device co-host? Thank you very much. So we're going to be kickstarting right about now. So 1 second while I just share my screen. Okay. All right. Okay. So I think we're good to go. So welcome everyone. Welcome to this 10 Analytics Tech Series Masterclass. All right. So this is going to be a very interesting session where we are going to be learning how to predict heart disease using Python. So this particular session is tilted for professionals that are looking to get into the data science space, looking to get into the data analytics space. All right. So, and why is this? Because we're going to be using a tool, a particular programming language, right, and which is widely known called Python. This is a multi-purpose programming language, but we are going to be using it to build a machine learning model that has the ability to be able to predict into the future. Okay, so we're going to use our machine learning models to train a couple of data sets and then, have this model predict, for us. All right. So it's going to be an amazing session, right? So I want us to really get comfortable before we get into, before we get all serious. Okay. So now, if you are, or rather, I want us to drop, our names and where we're joining us from. Okay, let's start with that. Okay, so let's start with that. So my name is Mubalaji. I'm joining from Ghana. All right, my name is Byron. I'm joining from the United States. I want us to throw all of that in the chat before we get started. Okay, so this is going to be a very engaging, a very interactive session where you get to be able to ask all your questions, you get to learn as much as possible. All right. Well, I want us to get started by introducing ourselves in the chat. Okay. So I want us to drop our names and where we're joining the session from. Okay. So like I said, okay, fantastic. We have Adedayo joining from UK. All right, we have Dorcas joining from Lagos. All right, so let's keep that coming in. All right, let's keep that coming in. So your name and where you're joining the session from. Okay, so I want us to get really comfortable. We have a lot to learn this evening. All right, and there's also if we have a special, free gift, like a discount package for us again this evening. So there's a lot to learn. You're going to be learning. This is a free program. We're going to be learning how to, make use of tools like Python, machine learning, right? And then we also have freebies at the end of the program. So it's going to be an amazing session. Why don't we get really comfortable and, introduce ourselves? So again, if you're just joining us, you have not missed anything much, right? We're just basically introducing ourselves, right? Dropping our names and the location that we're joining from. So we have Moses from UK. Hi, Moses. You're welcome to the session, okay? So if you're just joining, you can drop your name and your location in the chat. So now, this is going to be an interesting session where you have a lot to learn. All right. And then the slides, right, the recordings of this program, okay, they are going to be made available to us at the end of the program. All right. So there's a lot of things to learn in this program, but the only way you can get access to all these resources is if you fill in the attendance form that is going to be passed in the chat box by my colleagues. All right. So we're going to have a couple of attendance forms, right, passed in the chat. All you have to do is go ahead, fill in those forms, and then you can get access to all of the resources and the recordings of this particular session. So now let's jump into what we have. Okay. So what are we going to be doing today? We are going to be predicting heart disease using Python as a newbie machine learning engineer. So if you are a newbie into the data science space or the data analytics space, right? If you are a newbie, you just started learning how to use Python, okay, you are going to learn how you can build a machine learning model that can predict into the future, right? What else are we going to be doing? Then I'm going to come in and walk us through the pathway to becoming a data analyst or a data scientist, right? So what are the steps that you need to take to become a data scientist or a data analyst in 2025? The fastest route, okay? I'm going to be showing us all of that. And then I'm going to be also walking us through the Analytics Growth Internship Program. And finally, a special discount offer to you. Now, that is for those that wait till the end of the session, okay? We have a special discount to you. So now, very quickly, Analytics, all right, a very quick one about us. So who are we and what do we stand for? So Analytics is a leading edtech firm that is helping Africans and people of the Black community learn premium tech skills and lower the entry barrier into tech. So basically, we exist to be able to bridge that gap between people landing their first roles in tech, fresh off the classroom, fresh off the university, or people that are looking to transition into the tech space from a non-tech role. And how do we achieve this? We have through our numerous course offerings ranging from data analytics to data science, data engineering, financial analysis, Scrum Master, cybersecurity, and so on. So we have over 8 tech career paths that you can begin your tech journey, in with us here at Analytics, right? So that is who we are in a nutshell. Now, a very quick one about me, right? I'll be facilitating this session. And my name is Mobolaji Faluba. I'm a data scientist and machine learning operations engineer with half a decade experience in data analytics and AI engineering. And my experience span data science and ML ops at Simplified UX USA, data analytics at Moist Consulting Canada, and AI engineering at Zara Health Limited, Nigeria. So I've worked in the health space, I've worked in the financial sector, I've also worked in the edtech sector. Right, so now we have a very, very seasoned professional with us here this evening, right? It's a privilege to have her. She is a seasoned professional. She is a professional data scientist. She's been in this space for a while. She's going to be coming in and showing us how we can get started as a machine learning engineer, how we can get started as a data scientist. So she's going to be showing us how we can build that model this evening, walking us through the entire process. So I'm going to let her come in and introduce herself. All right. Hi, Akuna. Good evening. Welcome to the session.
All right. Hi, Mobolaji. Thank you very much. Hi, everyone. Happy to be here as well. All right. So my name is Akuna Anyampa. All right. And I'm a seasoned technology professional. All right. So I have experience as a data analyst, and I also have experience as a data scientist. All right. So I also have over 5 years, all right, of experience, spanning diverse industries from sales to health to security, IT, telecom, education, marketing, NGO collaborations, and so on. All right. So I've definitely also worked with prominent, people and companies around the world, spanning from US, Ghana, Cameroon, UK, Canada, Nigeria, and other parts, all right, of the world as well. So definitely you are in the right hand, all right? So at Analytics, I'm a senior data science associate, all right? I've trained well over 500 professionals globally, all right? I've equipped them with skills that has helped them, become outstanding, all right, in their various career set out paths. All right, so definitely that's what we are here for. We're committed to your change, committed to making sure that you're outstanding, not just a normal tech professional, but someone that is outstanding and valuable in the industry. So that is what I would help you become. All right. So thank you so much. Over to you, Balaji.
Thank you very much, Akuna. I mean, I cannot wait to get started. I cannot wait to learn, have you bring all those magic and, let's get started. So I'm going to stop sharing my slide right now and have you, take over the entire session. So Akuna,
All right. Thank you very much, Mubolaji. All right. So I'm just going to share my screen and you're going to see what I have on my screen. Okay, there we have it. All right. So this is where we stopped. Okay. Nice. Nice. All right. So today we're going to do something really amazing. All right. We're going to be predicting heart disease using an existing data set that will be shared to you later on. All right. We're going to use Python as our programming language to predict if a patient has heart disease or not. All right. So that's what we're going to do today. And you ask me, all right, so how are we going to go about that? Don't worry. I'm going to show you how we are going to go about that from start to finish. All right, so a very quick one. I want us to be interactive today. So I have a question. Have you ever been to a hospital, for instance, and the doctor took in some of your details and gave you a diagnosis? Anybody? You can use the comment section. Have you ever been to the hospital and the doctor, took in your diagnosis, your details rather, and give you a diagnosis? Anybody? Good. All right. So for instance, the doctor could have asked you, okay, do you have previous health records? What's your age? What's your BMI? That is your body mass index. All right. Who check in your BP rate, your BP value, things like that. And once they're done checking all they want to check, getting all the parameters and all the features that they want to get, then they give you, they predict to you. Okay, that's the word, they predict to you. They predict what's happening to you. They tell you, okay, based on what you have given us, this is what is happening to you. This is the health issue you're having. Do you know that's an application of data science? Anybody? Do you know that's an application of data science? Yes, that's an application of data science. You get in some data from someone and then you analyze it. You observe trends, you observe patterns, and then you give the person a prediction. You say, okay, based on what you have said, based on what we know, what we have learned from previous data, this is what is happening to you. And that is what we're going to do today. All right. So that's just a summary of what we're going to do today. We're going to get previous data, would analyze the data, would train a model, and then would predict if a patient has heart disease or not. Yes, it's that simple. It's that simple, but definitely is more technical behind. So let's move on. Let's move on. We have quite a lot of things to do today. So now who makes this possible? A data scientist makes this possible. A machine learning engineer makes this what? Possible. All right, so data scientist is a combination of data analytics, and then you can move on to model development and all of that. So it's more encompassing, all encompassing, all right? Why machine learning engineers? They are focused on building models. They are focused on evaluating models. They are focused on improving models, all right? And other things that they also do, all right? So today, we're going to act as data scientists / machine learning engineers for the company that we're going to be working for today on this particular project, okay? So let's move on. So today, we're going to use a tool called Jupyter Notebook, and we're going to program, all right, and write our codes using a programming language called Python. How many of us know Python? How many of us have ever heard of the programming language called Python? Wow, none of us. Okay, Adedayo says yes. All right, me, good. Any other person? Okay, so Python is a programming language which you can use to do lots of amazing stuffs, all right? You can use Python programming language to create games. You can use Python programming language to train models that can forecast, that can predict the future. You can use Python and programming language to create amazing dashboards. You can use Python programming language to draw. Yes, you can actually draw using Python programming language, using a library called Turtle. There are so many things you can use Python programming language to do. You can also create amazing websites and apps using the Python programming language. But for today, we're going to focus on using Python programming language to train a model that can predict what is wrong with our patients. All right, so let's move on. So now I want us to take a look at the deployed application. All right, so I'm going to stop sharing the screen. and I'm going to show you what we stand to do today, what we want to do today. All right? I want to create something amazing, and I want you to have a feel of what we want to create today. So what we have on the screen, okay, as you can see on the screen, what we have there is an application, all right? And this application is used to predict whether a patient whose details have been imputed into the system has heart disease or not. So now let's look at this first patient, all right? So they say their heart disease prediction app, right? Provide the patient details below to check for risk of heart disease, right? Good. So let's go down. So we have the gender, all right? We have male, female, so I can just choose male. We have chest pain type. Okay, we can choose anything. All right, so you can also put anything basically. All right, the link will be shared to you later or with you later, and then you can have a feel of the application. So I'm just choosing anything basically. I just want you to know that this works. All right, so I'm choosing anything. I'm just choosing anything, all right? So these are various features that we're choosing, various details of our patients that we are imputing right now into the system. And once you're done imputing that, you will look over here and you see the patient input data. So whatever you imputed up, if you come down, you see it here in this table below, showing the sex, the CP, the BPS, the FBS, everything. All right, so all of these are medical terms. All right, so you put all of these things, and once you're done, you predict. You click on the button over here and you say predict heart disease. And voila, the prediction result tells us no heart disease detected based on what we actually imputed. All right, so you can change the inputs now to something different, and it ends up telling you, oh, hello, this patient actually has heart disease. All right, so we're going to show you how to do this today. Okay, so I'm going to show you how to train the model that makes you predict this. Okay, so for the UI, the user interface, I won't have time to show you today. All right, but another time, okay, once you join the program, you'll be able to learn how to create the exterior, all right, the user interface that you are seeing here. All right, so let's quickly move on to the next item on our list. So very quickly, I want to show you the plan for today. I want to show you what we want to do today, right? So you can see the plan on the screen. We call it the flow charts. So what are you going to do? Because anytime you want to program, you should have an idea of what you want to do, all right? The steps you want to take before you can reach the final destination, all right? You must have that at the back of your mind. But before that, I want to share with you the data set so that you can have an idea of what we actually have in our data sets. So our data set contains records, okay, of different patients in this particular establishment, in the particular hospital. So as you can see on the screen, we have about 1,026 rows in our data sets, okay? And this is what we're going to use to train our model. So here you can see age, you can see sex, you can see CP, you can see BPS, you can see cholesterol, everything. Right, you can see similar things, familiar things that we had to impute to make the predictions, remember? So you can see all of that here. So every row here represents a person. Every row here represents what? A person, okay? So you can see that. So how is it going to work? What do we want to do right now? We want to predict what we have here, the targets. So 0 here means this person does not have heart disease, while 1 means yes, this person does have heart disease. So 0 is no, and 1 is yes. Okay, so this is the data set we are going to use to make our predictions. Okay, and once we are done predicting, we're able to input some of these values and tell us yes or what? No. So I want to be sure that we understood what I just said. If you did understand what I just said, please kindly go to the comment section and tell me, oh, I understood. Very important. Yes, the data set is going to be shared with you, don't worry. But if you understood what I just said, all right, beautiful. So I'm going to move on. I want to make sure that we're all on the same page. So now let me show you the flow of our class for today. The flow of our class for today. So we have the flow charts. So So for the flow charts, we can see over here, we start the project. That's the first thing you're going to do. You start the project, then we have import the data sets. So once you're done, you import the data sets, which I just shared with you right now. Afterwards, you then explore the data. You need to understand what you have in your data. Before you start making predictions, you can't just start making predictions. You must understand what is in my data. What are the columns in my data? What do I have in my data? Are there missing values in my data? Are there anomalies in my data? So at this stage of exploring the data, that is where you take care of anomalies, wrong formatting in your data, and so many other things. So once you're done exploring your data, you then move on to the next stage, which is what? Splitting the data. Now you're ready to train your model. Now you're ready to what? Train your model. So you're going to split your data into the training and the testing sets. Okay, please kindly give me a minute. Let me just adjust this. Okay. All right. So you're going to split it into the training and the testing sets. So after splitting it into the training and the testing sets, you come down to what? Scale the data. We're going to do all of this today, all right? But I just want you to know where we're coming from and where we're going to. So it's important for you to scale your data so that your model can get trained faster, all right? You must put everything on the same plane. That is what we call scaling. All right, so for instance, if you're having variations of different values, yeah, you're having 1 million, yeah, you're having 72, things like that. You're going to scale everything down to a particular range whereby you can have all your ranges between 0 and 1. I'm going to show you how to do that. Don't worry. So once you're done scaling the data, the next thing you're going to do is you're going to train the model using the scaled data. And so by so doing, once you train the model using the scaled data, you see that it's going to be what? Scaled, it's going to be trained faster and more effectively. All right? So afterwards, the next thing you're going to do is you're going to evaluate the model that you have trained. How do you know your model is performing well? All right? Is it just, you can't just create something and no one tests it and tells you that, okay, this is good. All right? So you have to evaluate the model to make sure that your model is performing very well, that it is accurate to a very large extent. All right? And once you're done, so once you're done, you're going to end the entire process. Okay? So let's move on. Let's move on quickly. So please give me a minute. Okay, sorry about that distraction. Okay, so now we're done with that. The next thing we're going to do now is let's move on to the coding aspect of this project, okay? So over here, as you can see on the screen, we have our Jupyter notebook already opened, all right? So you already have what you want to do. You already know where we're coming from and what you want to do. So now we're going to start by importing the data sets, okay? And if you want to import the data sets, you have to import what we call Python libraries. You can't just start importing a data set like that. You need something more like tools. These Python libraries are tools that you use to perform different tasks in your Python environment, more like your spoon and your fork, right? If you want to eat, you make use of the spoon and the fork to eat. So now we're going to make use of different Python libraries to do different things in our Python environments. The first thing we're going to do now, let's look at our flowcharts, is to do what? To import the data sets as you have on the screen, all right? So let's go back. So now over here, I'm going to click here, and I'm going to click another cell. And over here, we have the libraries that I want to import. So I'm going to get the libraries that I want to import from another tab, and I'll paste them there, okay? So prior to this training, I already got everything ready, all right, so that we don't waste time waiting for me to finish typing, all right? So I'm going to paste that here, and we have about 1, 2, 3, 4, 5, 6, 7, 8, right? We have like 8 libraries that we're going to use here today. Okay, so as we go on, I'll tell you the library that we're using for whatever it is that we want to do. Okay, so now we're going to start. Now in Python, once you type in a code in your Jupyter notebook, you have to run that code before you go to the next cell. So I'm going to come over here and I'm going to do Control Enter to run the codes in this cell before I move on to the next cell, right? So it's still running. And while it's still running, I'm going to bring in the next code to import the data set now that I'm done importing the libraries that I'm going to use, to train my model. So now I've come to the next space. I'm going to bring up the code that I want to use, all right, to import my data sets. So I'm going to come over here and I'll run this. And if you look at this, okay, if you look at this clearly, if you zoom in and you look at this clearly, if you look at this region, you see that what I showed you earlier on in our Excel file is actually what we have here. You can see age, you can see sex, you can see CP, you can see BPS, you can see col, that is cholesterol, FBS, and the rest of them. And over here, you can see the target. So indeed, we have, accurately and successfully imported our library into our Jupyter Notebook environment. So that's the first win for us. Now that we're done importing our library, we can go to the first step, which is step 1, where we're going to explore the data set. Remember in our flowchart, we had what? Explore the data. So now we need to explore the data. I'm going to create another cell here, and I'm going to start exploring the data from here. So let's explore the data. Let's check our data and see if we have missing values in our data. Let's check our data and see if the columns in our data have the right formats. Okay, you don't want a situation where your data set in your Python environment is seeing your age as a character. Age is what? Number, right? Ages are supposed to be related as what? Numbers or integers. Okay, you don't want a situation where you're seeing it as a text. Okay, so these are the things we're going to look out for right now. So for me to do that, I'm going to use df.info and df.describe. All right, so these are used in Python while you are making your analysis, right? For me to do that, I'm just going to bring that over here, and I'll bring this over here, and I'll just change it, describe. So I'm going to run the first thing. Remember I told you have to run everything step by step. So let's run the first part. Beautiful. So over here, you can see age, you can see sex, you can see CP. Now, if you look at that, you can see from over here, you can see that we have 1,025 rows throughout. What this tells you is that there is no column that has missing values. All our columns have values in them, right? All the cells in our data sets, they all have values in them. None of them is empty. So that's a good winner as well for us. Now, if you look at here over for the D type, okay, we have the data type there, which shows you the formatting. And I can see age is seen as in 64, which is integer. We can see, okay, sex as well is in 4. So the sex was converted, that is gender. It was converted to numbers, all right, 0 and 1. And that is why you're seeing it as what? Integers, which is actually okay. All right, so I'm looking at what I have here on my screen. Everything is integer, float, integer, float, integer, float, integer, float, and it looks good, actually. Everything is good, all right? So let's move on from that. And we have no missing value, but we want to check further to make sure that our data set is actually okay. So I'm going to use df.describe to further explore our data. And from here, I can see that under age, the count is also 1,025, meaning there are no missing values, all right? And I can also see some other things here, which shows that our data set is actually okay. So our data set is actually very much okay, and we can move on to the next stage of exploring the data. Okay, so with time, as you practice more as a machine learning engineer, you will get to know other things you actually look out for, right, under the summary, the data set summary. Okay, that is what we call this, the data set summary. With time, you get to see other things. But for now, if you look at this as a beginner, just look out for places where you would see the number of rows, and make sure that it tallies throughout all the columns, meaning you have no missing values. And if you have no missing values, you can move on to the next stage for now. So we're done with that. We are done with that stage. Now, the next thing I want us to do is still under exploration, is I want us to further explore our data set, okay? Remember, we want to predict if a patient is what? has heart disease or not, okay? So if you want to do that, do you want to start using all the features in your column? No, you will not want to use all the features in your column. So what am I talking about? Let me show you what I'm talking about. So in our column, remember we have age, remember we have different things, okay, sex, etc. All right, so if you want to predict the target over here, you don't necessarily have to use all of this to predict this. You can choose to select one of it or 10 of it, 10 of them. Choose the ones that you want to use to predict your target feature over here, to predict whether the patient has heart disease or not. You don't have to use everything. You don't have to use all the details. All right, you don't have to. So this is what I want to show you how to do. I want to show you how to select what to use to predict your target feature, which is to predict whether the patient has what heart disease or not. Let's pick the columns that we're going to use to predict that very fact. Okay, so for us to do that, we're going to do what we call correlation. We're going to check the relationship between one feature. For instance, we're going to check the relationship between age and this target feature, which is telling us whether the patient has heart disease or not. We're going to come over here and check the relationship between sex and the target feature to see their relationship. Let's move on from that. Let's go down a bit. All right, so we're going to continue from here. Okay, I can just delete this. All right, so from here, I'm going to bring up the code that we're going to use. All right, and now we're going to use matplotlib. All right, matplotlib is a library in Python which is used to what? It's used for what? Visualizations. All right, with time you're also going to get to know more about the matplotlib library. All right, so I'm going to come over here. Okay, so I'm going to come over here and I'm going to do Control Enter. So this is the correlation map. Okay, so what does this actually show you? In summary, what does this actually show you? This correlation heat map shows you the relationship between different features. Okay, so I don't want you to get overwhelmed. If you look at this correlation map, what I just want you to look at and focus on is what you have over here, where my cursor is. Just this last line over here, all right? Where you have targets, you can see 1.00, followed by minus 0.34 and all of this. So all of this actually show you the correlationship between different features and what you're trying to pick and predict. Okay, you're just trying to check what a relationship between all of them. Okay, now to further buttress this and to make things even easier for you, we have what to call there are different kinds of correlations, different kinds of relationships. Some people have strong relationship, right? Some people's relationship is weak. Okay, so we want a situation where we go for columns that actually have strong relationship with our target feature. What does that mean? For instance, if the age is increasing, all right, and the target feature is also changing, we want to see that kind of relationship. But we want to know if as the age is increasing, people whose ages, who are getting older, if they're actually prone to having heart disease, things like that. We can get to know that from here. So I'm going to go down a bit and I'm going to bring up this for you. So I'm going to show you what you can do. And whatever I'm showing you right now was actually gotten from that correlation map, but I had to break it down so that you can actually understand it better. So for us to select what we're going to use to predict the target feature, I'm going to check for features, all right, or columns that have a strong relationship, a strong positive relationship with what we're trying to predict, which is the health status of the patient, the heart health status of the patient, and those of them that also have a strong negative relationship with the health status of the patient. All right, so I'm going to come down here and I'm going to get the features. Remember, what we are trying to do is to do what? We are trying to select the features that we're going to use to predict whether the patient has heart disease or not. That is what we're trying to do. I'm just trying to get the features. So I'm going to paste this here and I will have this here. And if you look at what we have here, you can see most positively correlated features. Okay, so those of them that are positively correlated with the target feature, you can see them here. You can see target, you can see CP, you can see slope, you can see FBS, right? Different features in our data set are already outlined here. So what this means for us is that all of these columns, any column that you see that is named CP, any column that you see that is named slope, any column you see that is named FPS, and so on, we're going to use them to predict whether a patient has heart disease or not. But we're not done. We still want to add more features to it, all right? So we have gotten the first 5, or rather the first 6 most positively correlated features to the target feature. Now let us get the first or the last 3 or 4 negatively correlated features to the target feature. So let's go down and let's look at that. So I'm going to get the code. That's what I'm trying to do. I'm bringing out the code so that we save time. And then you see the output of the code. All right. So we have it there. So now we have seen the most negatively correlated features here. So you can see sex, you can see SAL, you can see CA, you can see old peak, you can see different columns, all right, from our data set. You can see those of them that are negatively correlated, that are most negatively correlated, all right? You can see all of them from here. Let me just adjust this. Good. So you can see all of them already outlined there. So what this means is that we're going to use these features. These are, let me check, 1, 2, 3, 4, 5. 5 over here. And let's go up, excluding the targets. 1, 2, 3, 4, 5. Right, so we're going to use 10 features in total to predict if our if our patient has heart disease or not. We're going to use 10 features. In our data set, we have 13 features. So instead of using the entire 13 features, we have chosen 10 features, all right, to use to predict if our patient is having heart disease or not. So now that we're done making our decision and we have chosen the features, now we can move ahead to prepare the data. Now, under the data preparation, for the data preparation, we are going to start splitting our data. Okay, we want to split them into the data that we're going to use to train our model and the data we're going to use to test the model that we have trained. So we call it the train model, the train sets, and the test sets. Let me come again. Now, at this stage of preparing the data, we're going to divide our data set into 2. The first is going to be the train set, which contains the part of the data set that we want to use to train our model, and the test set, the part of the data that we want to use to test the model that we have already trained using the train sets. So that is what we want to do now, all right? And for us to do that, I'm going to show you the code that we are going to use. I'm going to show you the code that we're going to use. So don't get yourself overwhelmed. This is your very first machine learning class. All right, I just want you to understand the process. Then with time, you start digging deeper to understand the syntax, understand why we have to do some of the things we're doing. So right now, just understand the overall flow, all right? That is what you should do right now. So now this is what I'm doing. If you come over here to the X, which is the inputs, and Y, which is the output, okay? So Y is actually what we are predicting, which is the target column, the target feature. Yes or no. Yes, the patient has heart disease. No, the patient doesn't have heart disease. All right, so that is for the Y, all right, over here. And Y, the X, you know, all of those correlation we're doing earlier on up, trying to select the features we're going to use to predict whether the patient has heart disease or not. We are putting all of them up here. Right? So we're putting all of them up here. I'm just going to zoom in a bit. Good. So I'm putting all of them what? Up here. Under X. Right? So X contains all of that. Okay? So don't worry, don't get yourself overwhelmed. What we're trying to do is to train and split everything into the train sets and the test sets. Okay? So let's move on from that. So let's move on to the next cell. We are not done. We have not divided it yet. So now I want us to divide it into the train and the test sets. So for us to do that, we're going to use this line of code, right? We're going to use the line of code that I'm about to send. Good. So I just executed this line of code. And as you can see on the screen, we have x train, x_train. This is the train data, x_test. This is the test data, y_train. This is the train data for y, and y_test. This is the test data for y, right? So now we have successfully split our data sets into the training data for training our model and into the test data for testing what you have trained, so that we'll be sure that what we trained is even working well. So let's go down. Now we're done splitting. Let us move on to the juicy part of the training. Let us train our model. And to train your model, there are many things you can do. Okay. Before we train our model, let's scale. Remember, I spoke to you earlier on about scaling, right? Let me show you what it means to scale. All right. So I'm just going to go back here and I'm going to send this code over here and I'm going to execute it. This is scaling, but you might not understand what I mean. So let me show you what it means to scale. So we have to scale our data set once we are done dividing it into trained and test sets. And once we are done, we can now train the model, but we have to scale it before we can train the model. So let's go up a bit. So look at what you have on my screen. I have something on my screen. I want to show you what scaling is actually. So on the left-hand side, all right, on the left-hand side, you can see age, you can see BPS, you can see coal, you can see. So all of these were actually extracted from our data sets, okay? So you can see over here, we have 63. Our first patient over here is 63 years old. You can see 145. You can see 233. You can see 150. All right. The next patient is 37 years old. We have 130, we have 250, and we have 187, right? And it goes on, it goes on. So what do I want to do now? I want to put everything down. I want to scale everything down to a particular range of values so that we can train better. Our model can be trained better. So now let's look at the scale data so you can see the difference. Now, the age is now what? Instead of having it as 63, we now have it as what? 1.24. Instead of having it as 145, it has been scaled to what? 0.76, all right? So we have scaled everything down to a particular range, a range of maybe -0 up to a particular value, let's say 2, all right? So everything has been scaled down to a particular range, all right? Now you ask, does it lose its value? No. So when you scale things down, it still has its magnitude. It's still okay the way it is. It does not change. The magnitude of 145 for this particular magnitude of 63, for instance, in this particular age column, all right, is still the same as 1.24 on this particular column, but we just scaled everything down. You know what it means to scale? You're just bringing everything down, all right, but it's still having its worth. Its worth is still the same. Right, that is what we mean by scaling. So the code I just executed helped us to scale down, all right, our values in our data set so that it can train faster, it can train more effectively and efficiently for, for the best and the optimization of our model. So I've gone back, all right, let's move on with what we are doing, all right? So that is the scaling. So we have scaled everything down, all right, and our data sets is okay now. So now let's move on to training the model with our scaled data. Now for us to train the model, there are so many algorithms out there. In essence, there are so many formulas out there in the world today, all right, that you can use to train your model. There's so many algorithms there, okay? But for today's class, for today's masterclass, we're going to use the logistic regression, all right? We're going to use it to train our model. We're going to make use of logistic regression. We have random forest, FVM, we have decision trees, XGBoost. There are so many algorithms out there today, but let's all stick with logistic regression. Okay, so I have it here and I'm going to run the code. So now we are training our model. That's what we're doing. We are training our model. And once you're done training the model, now the model has been trained. And that is why you're seeing this here. Okay, now the model has been trained. So now let's move on to evaluate our model. Now, what is model evaluation? Now you're done training it. you need to test it, okay? You need to test it with the test data. Remember, we have trained it using what? The trained data. So now let us test what we have trained, okay, using the test data to see if our model performs well, to see if our model is accurate enough. So that before we deploy it to what I earlier showed you at the beginning of the training, was to be performing well, because you don't want to deploy a model that is not high performing. So let's go down and let's do this quickly. All right, so from us to train the model, I'm going to use model.predict. Or rather, first evaluate the model, sorry. I'm going to use model.predict, and then it's going to bring up what to call a classification report, okay? So I'm just going to put this over here, and I'm going to run this. Just be patient. Then I'll come down, and I'll put that as well. Okay, sorry. Oh yes, so when you're writing your codes, you can have errors. So if you have errors, it doesn't mean you're not a good programmer. It just means you made a mistake, and you can always go back to cross-check what you have done. Okay? To cross-check what you have done. It's not NASA mathematics, all right? It's something that you can always go back to cross-check. And even if you can't see the issue, you can always copy your errors and send them to some of these AI tools like ChatGPT, Google Bard, and the rest of them to see where your error is coming from if you cannot get where the error is coming from, all right? Because it happens. It happens. So I'm still trying to bring up the classification reports. That is what I'm doing. I'm pasting the code so that we can get the classification report, which is going to contain the results of our model evaluation. Good. So now we are done. We are done testing our trained model using the test data set we earlier splitted it into. And now we have our classification reports. So as you can see on the screen, we have the classification reports over here, right? So there's a lot of information here, okay? But what concerns you right now as a beginner is this, is that we have 0.82. Okay, so 0.82 there is your accuracy score. So if you multiply it by 100, it's going to be what? 82%. So our model, out of 100%, has an accuracy score of 82%. That is relatively good, right? That's good, right? For a start, that's good. Although you can do one or two things later on to this model to bring it up to, let's say, 95%, to bring it up further to, let's say, 100%, okay? So there are different ways you can do. You can do hyperparameter tuning and so many other things to, make your model more optimized, okay, and more accurate. But for now, our model today is what? Performing by what? 82% rate of accuracy, which is okay, all right? Which is okay. So now once you are done and you're satisfied with the model that you have trained, the next thing you're going to do is you're going to save the model that you have trained. You're going to save the trained model, okay? And how are you going to save the trained model? Earlier on, we imported a library called joblib over here. So far, during our process, we've been using all these libraries over here. We have joblib, which we want to use now to save our model. We use pandas as well. This is what we use to import our data sets. You have Seaborn. This is also what we use when we are trying to get the correlation and we beautified it. We have different things. We have the standard scaler here. This is what we use to scale down our data sets. We have logistic regression. This is what we just use to train our model. We have train, test, split. This is what we use to split our model into our data set into the train and the test set, remember? And then we have accuracy score here. We have classification report, which is what we just used now, right? You can see that every library, all right, every library was used, all right, during this process. So libraries in Python are very important for you to use to do a lot of things in Python. Python exists on libraries, all right? So now we're going to use joblib, all right, over here to save the model that we have trained. So I'm going to come over here and I'm going to get the code and we're going to save our trained model. So saving your trained model is not the same thing as saving your code. No. All right. You're going to save your trained model using JobLib. All right. I'm going to do this now. And you can see this text over here where we have hats_model.joblib. Now our trained model has been stored in an external file called hats_model.joblib. So if I go back, all right, to where my file directory is, I can see the model that I just stored over here. And if I even go down to my downloads or my documents, wherever you have your Jupyter Notebook linked to, you will see another file, a standalone file somewhere. You see it. It will be called hats_model.joblib. This is the model that we just trained. And this model we just trained now is the model we will take to the back end of the Streamly app that we actually created earlier on, as you can see on the screen. So that model we just created and saved in that file, the Joblib file, is the brain behind this application you're seeing on my screen. This is what makes the prediction possible. So that's powerful. That's powerful. And what happens as a machine learning engineer? Let's say you don't even know how to create apps like this. You don't know how to do the front end and all of that. Once you're done training your model in your beautiful office, wherever it is you're working, all right, you can train the model, save the model as the Joblib file, as a pickle file, whatever format you want to save it as, all right? And once you're done, you send it to the developers, send it to the website developers, the engineers, all right? Those of them that build apps. You can send it to them and then they can integrate it with the applications, and then you have something like what we have on our screen. So that is what we can do as machine learning engineers. Are we here, please? Was that very fast? Are we here? Okay, if you understood what we did today, kindly give me a thumbs up, or better still, tell me, oh, I understood. If you understood most of what we did today, kindly tell me. Okay, so I can see yes from Gozier. Any other person? All right, all right, all right. So this is what machine learning is really about, okay? This is what it's about, okay? But very quickly, I want to be sure that we actually did understand what was done today. So I have a very quick exercise before I hand over to Mobolaji, all right? And that's what we have on the screen right now, okay? So I'm going to ask a question, and then in the comment section, all right, you tell me the answer, okay? So the first option is A, the second option is B, and the third option is C. So if it's A, you put A. If it's B, you put B. And if it's C, you put C. Let's be sure you understood what we did today. All right? So now, number one, what is the goal of the heart disease prediction? What is the goal of the heart disease prediction project? A, to predict if a patient has heart disease. B, to collect weather data. And C, to detect diabetes. All right, so I'm seeing A. Let's keep it coming. Let's keep it coming. All right, I'm seeing A. Okay, so I'm going to click on it, and it's going to tell us if A is actually correct. Okay, so I'm going to click on A. Correct, so you're actually correct. So let's go to the next one. So why do we scale the features before training? To clean missing values, to increase data set size, to ensure all features are on the same scale. So let's give me the answer, please. All right, okay, I'm seeing C. Okay, so I'm going to go to C. Correct, that's good. All right, so let's go down a bit before I round up the session. Which model was used in the project? So what did we use to train our project? Did we use decision tree? Did we use logistic regression? Or did we use random forest? Oh, beautiful. That means we're listening. Good. B. So that is logistic regression. Good. Good work, everyone. Now, the next one is, which column is the prediction targets? What column were we actually predicting? Were we predicting age? Were we predicting cholesterol? Were we predicting targets? Is it A, B, or C? So we're actually predicting C. All right, that's correct. Now, what's the purpose of the train test splits? To remove outliers, to balance the classes to evaluate model performance on unseen data? What's the answer? What is the purpose of the train test split? Okay, I'm seeing B, that is to balance classes. All right, another answer. Okay, I'm seeing C, to evaluate the model performance on unseen data. All right, let's check. So I'm going to start with B. Okay, I saw B from Abimbola, so let's click on B. Okay, the answer is not B, Abimbola. It's not to balance classes, so let's go to C. So the correct answer is actually C. So a couple of us actually got it. To evaluate model performance on unseen data. Beautiful. Now let's move on to number 6 and then the final one, question 7. What library is used for data scaling? sklearn.preprocessing, matplotlib.pyplot, pandas.io. Can anyone guess? All right, so we actually use sklearn.preprocessing. All right, great talk, everybody. I'm really impressed. sklearn. So if you look at the library currently, you see it, sklearn.preprocessing. And finally, what metric helps us evaluate the classification performance? Line plots, word cloud, classification reports. What's the answer, everyone? Let's echo it in the comment section. C, good. Classification reports. I'm going to submit all. And kudos to everybody. Thank you so much for having me today. I would give the floor to Mobolaji. Thank you so much.
All right. Thank you so much, Akuna. That was a very interesting session, right? I think you literally carried everyone along, right? So absolutely, hello, you can ask your questions, right? Just drop your questions in the chat. We are going to be getting to your questions in a bit. Okay, we're going to be answering all questions in a bit. All right. So Akuna, can you stop sharing so I can share? Thank you very much. So you can drop your questions in the chat. We're going to get into your questions in a bit, right? So that was a very interesting session. I'm sure that we learned a whole lot. So we learned who a data scientist is, right? What they do in an organization. We also learned, so you're going to be getting, so LOS, you're going to be getting all of the data sets. You will be getting the recording to this entire session. You're going to be getting all the slides that we've made use of, okay? All you have to do is fill in the attendance form that is passed in the chat. So there's an attendance form that is being passed by my colleague in the chat. All you want to do is go ahead and fill in that attendance, okay? And then you'll be able to get access to all of the resources, the data sets, and everything that was used in this session. So as I was saying, I'm sure that we learned a whole lot, right? So who is a data scientist, right? What do they do? What tools do they make use of? So we've seen how you can make use of Python to be able to build a machine learning model that can predict into the future. Now, this was a model that was predicting heart diseases, right? You want to understand that the application of machine learning is literally numerous, like it's uncountable. You can actually build a machine learning model that can predict employee attrition. What does that mean? The employees in an organization that are liable to, stop working for the organization. You can use a machine learning model to predict customer churn. Now, customer churn is letting you know, the customers that are currently subscribed to your product, to the company, but are most likely to stop subscribing to the company in a couple of, weeks or in a couple of months, right? So what happens is this. For example, when a company uses a machine learning model to get an idea of what can happen in the future, for example, we know a couple of customers that are liable to stop using our products. All right. Now, the company can, segment these customers, have the marketing team reach out to them, send them some sort of incentive just to keep them loyal to the business. We were able to identify beforehand, so before these customers left us, we were able to predict into the future. We saw that they might actually leave, and then we did something about it. So that is where you can come in as a data scientist, right? You will be very, very, the word is, companies would not be able to do without you. All right, because companies that know what you bring to the table, they would need you, right? You also have other applications of data science, right? Not just in machine learning, but also in computer vision. Okay, so you see all those speed cameras that are on traffics, right? And then they help you detect which particular car is over speeding out of like hundreds of cars that are on the road. It's because a machine learning engineer has been able to write an algorithm that can detect that particular event. So that happens in computer vision. Okay, so there's a lot of application to machine learning. So this is just your beginning. This is just your start point, right? There's a lot of things to learn. There's a lot of things that you can achieve, right, when you start your journey. So now I know that the next question that is going to be on your mind is, okay, Mobolaji, how can I get started? I've seen a little bit of the magic that Python can do, how I can predict into the future. This is somewhat like a superpower, right? You can be able to predict into the future, right? So how can I get started, in this career path? And then other people have questions like, Mobolaji, can you assure me that I can learn this, data science program? Can you assure me that I can understand Python? A lot of people are scared of Python, right? They have a lot of phobia for Python. So can you assure me that I can learn? All right. I know some people are going to have questions like, well, I just say, I don't have a background in tech. I did not study computer science, computer engineering back at school, right? I probably did biology, I did psychology, I did agriculture. How can you assure me that I can transition into this tech space and land a role without this background? Okay, so don't worry, I'm going to be giving you all of the clarity to all those questions. And I'm also sure that some people will have a question as to what is the market propensity like for this role? So data analyst, data science, right? Are they jobs that are in high demand? Are they jobs that are not going to be wiped away by AI, right? Is it safe for me to transition into this career path? So like I said, I'm going to be giving us all of that clarity in just a bit. So now, what we have done at Tenalytics is before we picked any program that we are training, here at Tenalytics, that we train for here at Tenalytics, we went on all of the top job boards out there. You can name it: LinkedIn, Indeed, Glassdoor, Total Jobs. What we did was we scraped all of these job boards, and then we picked the top performing jobs. And then we filtered all of these jobs through three major lenses: ease of learning, ease of transitioning, and high rewarding salary. So you want to be, you want to be sure, right, that any program that you decide to come in and register with us here at Analytics, they are programs that are easy to learn, okay? They are easy to transition into, meaning you do not necessarily have to have a computer science background, a computer engineering background. You can easily pick up the skill, transition into these roles, and land a job. And then the third thing that you want to know is all of these programs, they have a high rewarding salary. So now, after our research, we went ahead to get an external validation from the World Economic Forum, WEF, right? So WEF is a professional body that releases the report of the future of jobs, right, on a yearly basis. And right, 2025, what they released was that they predicted that in the next 5 years, 170 million jobs will be created, right? And over 92 million jobs will disappear. So what that means, what that translates for you is before you start to upskill into any program out there, you want to be careful to make sure that the program you are looking to get into are part of the ones that are going to be high in demand, that are going to be created. You don't want to get into a role that is declining or that is standing a risk of being wiped away by AI, all right? So we have also gone ahead to do all of those research for you. And what have we found out? We found out that we have a chart that shows us a list of the top fastest growing jobs out there. For the next 5 years, right, these jobs are going to be on the max. They're going to be on the increase, right? And in the next 10 to 15 years, these jobs are still going to be safe. Now, in the next 5 years, these jobs are pretty much the jobs we want to call the hot cakes. What are they? The big data specialists, fintech engineers, AI and machine learning specialists, software and application developers, and all of the jobs that we have on this chart. Now, the first one on the list, which is the big data specialist, is made up of three major classes, basically the data analyst, the data scientist, and the data engineer, okay? And we have all of this program here at Tenalytics. Now, if you come in for any of this program, for example, the data analytics, what are some of the roles that you can learn as a data analyst, okay? The roles are numerous. You can learn roles in marketing, right, as a marketing analyst. You can learn the role as a sales analyst, logistic analyst, supply chain analyst, and so on. If you come in for the data science program, you can learn roles in machine learning engineer, forecasting analyst, big data analyst, quantitative analyst, NLP developer, computer vision, and even AI engineer. So anyone that has any interest in getting into AI, because AI is the buzzing thing right now. AI is actually a subset of data science. All right. AI is a subset of data science. So if you want to literally get into the know-how, how do they create all of these AI applications? No, we are hearing of generative AI, right? AGI, we're hearing of agentic AI, all right? We are hearing of so many AI platforms out there, right? So how are these models, right? How did they come up with these models, right? So if you are interested in all of that, right, data science is the place to start, okay? And then, so now let's get into what are the things that we need, what are the processes that we need to take, right? What are the steps, right, that I need to take to get into the right path, okay? To get into the right path. So now, I have a question that I'm going to be asking us very soon. But before I ask that question, there was a particular tweet that Elon Musk, the richest man in the world, put forth on his X account very early this year, around, the 15th of January. And what was this tweet? So Elon Musk said, if you are a hardcore software engineer and you want to build the everything app, please join us by sending your best work to code@x.com. We don't care where you went to school or even whether you went to school or what big name company you worked at. Just show us your code. Now, when Elon Musk actually, tweeted this, it was generating over 20 million views. Right now, is way more than that. This tweet radically, caused a shift in the job market. And it actually does make sense, right? Because hiring managers and recruiters are no longer seeking for, applicants that just have a certificate to show for their skills or their supposed skills, right? So they need participants that can show us that they have worked on projects. They need participants that can show us that, yes, I have the skill, I have done this before, these are the tools I used, and those are the participants that are getting an upper hand in the job market as we speak. So now the era of certification is over. Nobody cares anymore. Show your skills and your experience. So people that are fond of going to, Coursera, Udemy, and, Udacity, and all of this self-paced, platforms to just do a crash course and try to get a certificate because they feel like that certificate is enough for them to land a role. It's a sorry case for them now because recruiters are not moved by your certificates any longer. They need to see what you have done, right? And I'm going to ask us, this is where I get to ask the question, right? It's a very, very simple conversational and engaging question, right? I'm going to need us to give me a response in the chat, right? So this is going to drive the point home as to what I'm trying to, bring to our notice this evening. What am I trying to bring to your notice? Now, let me ask the question first. Now, let's assume you are looking to make a trip. Now, you want to travel, okay? And in the morning, right, you got into your car, you turned your car key, but you discovered that your car is not going to start. So you're having car troubles, but you are in a hurry. You need to make your trip as soon as possible, right? Now, you have two sets of engineers to pick from to help you fix your car, right? The first one is a graduate from Harvard University from mechanical engineering, okay? But this particular graduate from Harvard, it does not have a workshop. It does not have a selection of cars that he can show you that he has worked on, okay? All he has to show you that is worthy enough to fix your car is a piece of paper that shows that he graduated with a first class in mech engine. And albeit that might be true, but he has nothing to show you as an experience that you can see. But on the other hand, you have this roadside mechanic, right, that didn't go to Harvard. But this guy literally has a workshop and is showing you a bunch of cars that he has worked on. So he has worked on Benz, he has worked on Aston Martin, he's worked on Range Rover, he has shown you a couple of tools that he used to fix all of these cars. So now here you are in a hurry to make your trip. Which of these mechanics are you most likely to give your car to fix your car for you so that you can make your trip? Now, if you'll be going for the Harvard graduate, I want you to put a this in the chat. But if you'll be going for the roadside mechanic, I want you to throw a that in the chat. So let me see who are the guys that are following me in this session, right? So if you are going for the Harvard mechanic, mech engine graduate to fix your car for you, throw a this in the chat. But if you're going for the roadside mechanic, throw a that in the chat. So let's go. I want us to really get engaging on this so I know if we have a clear idea of what we are talking about. So I'm waiting for our reply. If you are going for the Harvard engineer, throw a this in the chat. If you are going for the roadside mechanic to fix your car for you, throw a that in the chat. So who's following so far? So if you're following me, I want you to throw something in the chat so I know that you're following. All right, can we, get engaging? So if you are following what I just said up until now, I want you to throw a this in the chat or a that in the chat. So anybody following? Okay, so Juan is throwing a that, right, for the roadside. We also have Comfy throwing a that in the chat, right? Okay, good. So we're getting a lot of, votes for the roadside guys, right? The roadside mechanics, right? So even though this guy that went to Harvard, probably he actually got a first class from mech engine, right? So I think I have somebody who's trying to say, assuming that by all means the mech engine graduate is purely theoretical and has nothing to the on. Yeah, so that's the idea, right? DSKB. So the idea is this Harvard engineer might actually sincerely have graduated with a first class, right? Be it, albeit he worked on, theoretical projects or practical projects. But in this current dilemma that you are on, okay, it will be safer for you. You would feel safer to give your car to somebody who has practical experience that you can see, that you can vet for yourself, okay, rather than playing, a gamble. You don't want to gamble your trip, okay, on just a piece of paper that shows that, okay, I have a certificate from Harvard. You want to see a real life practical sort of experience right there. So if you, right, you are actually in this particular scenario, you would actually go ahead and pick this roadside mechanic that doesn't necessarily have this, fancy education, but has the skill, has the experience, can show you the things that he has done. Why wouldn't a recruiter go ahead and pick somebody who doesn't have a computer science background, who doesn't have a computer engineering background, but can use all the tools that is needed to get the job done? So they can use Python, they can use SQL, they can use Microsoft Excel, they can use Power BI, although they didn't go to school to get a BSc degree in computer science, but they have all of the skills and the tools to get the job done. What is stopping recruiters from hiring them? Absolutely nothing. The job market has absolutely shifted, right? So now, how does this come into benefit you? Regardless of the background that you are coming from, the old job market has actually absolutely shifted. Now, the barrier to get into tech-related roles has actually dropped. You can start your tech journey by picking up the most in-demand skills to land a role in tech. Okay, so now, what is the complete data analyst or data science toolkit that you need to land a job in 2025? So now I'm going to walk you through all of the skills that you need as a data scientist to land a role. First of all, you need to understand statistics. Okay, so we saw earlier when Akuna was using the df.describe, the describe function in Python. That is to show you the statistical analysis of your data. All right. So we're going to be teaching you statistics. 1 second, please. All right. So we're going to be exposing you to statistics, right? Everything you need to know about statistics, right? So your measures of central tendencies, your measures of dispersion, you're going to be understanding why a particular data set is symmetrical or unsymmetrical. You're going to be understanding how to detect outliers in data set using Z-score, the interquartile range, IQR, and all of that. Now, you're also going to be exposed to forecasting and predictive analytics using Microsoft Excel. So how can you use Microsoft Excel to predict into the future? You're going to see how that can happen. You're going to be learning Tableau for your data analytics. So Tableau is a business intelligence tool that is big on data visualization. So you're going to be learning how to use Tableau. You're also going to be learning how to use SQL. All right? They're learning how to use SQL. They're going to be learning how to use Python programming, which is actually a big one, okay, right? Python is actually the most important, tool of a data scientist. That's just true, okay? But here at Analytics, we have fantastic facilitators that are going to help you and train you from the beginner's level to the master's level as to how you can use Python, right? And then you'll be exposed to machine learning. That's what we did today in the introductory phase. You'll be learning how to do a whole lot of other types of machine learning. So what we did today was supervised machine learning. You'll be learning how to do unsupervised machine learning, right? And other types of machine learning, right? Then you're going to be learning computer vision, like I was saying earlier, right? Then ChatGPT and GitHub Copilot for coding and Microsoft Fabrics for analytics, right? So these are some of the tools that we are going to be using, and we are going to be teaching you as to how you can master them, all right? So now, I know people are going to ask this question, like I was saying earlier, what is the propensity of landing a job after I join this particular program? I don't just want to learn data science for learning's sake. I need to land a role, okay? A high-paying role at that. So now, yeah, at Analytics, we have what we call the job equation formula, all right? It is called T plus E equals job offer, right? What is T? Technical skills. These are all of the skill set that I just walked you through right now. statistics, SQL, Excel, Tableau, all of that. Those are the technical skills. And now we have the employability skills. So now, the truth is this, once you pick up the skills to become a data scientist, right? In reality, we have 1,001 data scientists out there. What is going to separate you from these guys out there? What is going to be giving you the edge, the advantage over all of these guys in the job market? And that is where we come in here at Tenalytics with the employability services, okay? So we are going to help you, number one, with your CV review and revamp. So how do you write a tailored CV that can land you an interview? If you need to get a job, you need to land an interview first of all. So how can you land that interview? You need a tailored CV to that particular role. We will be teaching you how you can do that. Next up, we're going to be teaching you how to optimize your LinkedIn profile. Last year alone, LinkedIn did over $10 billion in revenue. So LinkedIn is one of the highest recruiters of tech labor. So you want to be very visible on LinkedIn if you are looking for a job, a tech role. You want to be very visible on LinkedIn. Have a profile that is optimized, right? So we're going to teach you how to do all of that. We're going to teach you how to navigate the job market. What are the top job boards for remote roles, on-site roles, hybrid roles? We're going to walk you through all of this. And then we are going to also help you in your job hunt phase. How do we do this? At Tenalytics, we have gone ahead to subscribe to a lot of job boards, right? But these are premium job boards. These are job boards that you don't get access to their job offerings without paying to them. So we have gone ahead to pay to all of these job boards, and then we are scraping jobs and sending them to our students' profile, our students' LMS on a weekly basis. Now, how amazing is that? You are having premium jobs to apply to on a weekly basis. That would increase your chances of landing an interview to over 90% because you're not competing for all those jobs that are already crowded during the applications. These premium jobs, they have like a max of 10, max of 20 applicants. So with a well-tailored CV, you can stand out and land an interview. Now, when you land an interview, we at Tenalytics, we are going to prepare you for that interview before you go in for the actual interview. All right? And then when you land the job, we also will be providing you the job reference letter if you need one. And also, we provide the on-the-job support. So now you have landed a role, you're working on your new job. And for any reason, you come into any challenge working on a particular project, and you don't know how to go ahead with it, you can reach out back to us here at Tenalytics. Okay, we would have a team of professionals double down to you and give you that clarity and that soft landing that you need on your job. So how amazing is that also, right? And also you're going to be getting, weekly mentorship sessions, right? So we're bringing professionals on a weekly basis that are going to come in and train you, mentor you as to how the industry is, how you can, how you can make yourself more visible, how you can network, the pros and cons of the industry, and all of that. So you have weekly mentorship session, and finally, Upwork optimization. So these are some of the employability services that you are going to gain when you come in for the program. Now, this is just a screenshot, right, from a paid job board, right, that we scrape some jobs and send to our students. So these are premium jobs. Some of those jobs come with sponsorship. Some of them are fully remote roles. Some of them are hybrid roles, right? So we can see data scientists here at Shell. We can see a lead data scientist at the odds group, okay? So these are premium jobs with high rewarding salaries that we send to our students. So this is only for our students. When you join us, we'll be sending you premium jobs, when you are ready to start applying for jobs, right? So these are some of the things that you need to understand, as to what are the things that you are going to be gaining when you join the program, okay? And when you join Analytics to start your training, on your LinkedIn profile, you would not be putting there something like, I am learning, I am training at Analytics. No, what you should be putting there is, I am consulting at Analytics. So you can use Analytics as a job experience on your LinkedIn. Because in the true sense, we are a consulting firm and we get projects from a lot of our clients. And we bring some of these projects into the classroom for our students to work on. So you are actually working on real life projects, all right? And then you will be able to put Analytics, right, as one of your job experiences on your LinkedIn profile and on your resume. So now, I know somebody on this, on this call would have a question and say something like, so now, Balaji, can you tell me some of the people that have joined this program before and have been able to transition into tech, landing a data science role or a data analyst role, from learning from you guys? So I'm going to be walking us very quickly through some of our success stories. These are guys that are coming to the program and have landed roles with us. So you can see Abdul Rashid, okay, Abdul Rashid resides in Nigeria. He landed a full-time role as a data scientist with Child 420 in the US, working remotely after training with Analytics on the full stack data science program. So this is somebody living in Nigeria, right? And is actually earning in foreign currency, right? Because he's working remotely. Okay. We can see Bukola Adenuga, that's the lady to my right. She joined our data science program in September 2023. She completed her training and then she landed a job as a people's data scientist with a company in Poland, right? So this is somebody that is in the Europe, right, coming for our program, landing a role. We can also see Ubong here. So Ubong got numerous interview opportunities with PwC, right? And eventually landed a full-time job with Cognizant on the full stack data science program when he joined us. Okay, so this is another person that joined our program and was able to land a role. We can also see here Ebube. So Ebube got a job as a data scientist with the NHS. Okay, so I'm sure people in the UK, they are familiar with the NHS, okay? So she got a job, right, with the NHS. Obviously, this job is coming with full visa sponsorship, right? So she got a job with the NHS as a data scientist, right? So we have a lot of, success stories as to the guys that have come into our program, picked up a particular tech career path and then landed roles after they are done, right? So someone's going to ask me, so Mobalaji, how can I get started? What are the next steps? Okay, I need to get into this program and start my tech journey as soon as possible. All right. So now, the next step would be for you to register for our 5th of July cohort. So we have a new cohort that is resuming on the 5th of July. All right. And how can you get started in this program? How can you get started? So you can get started by going ahead to make payments, right, for the cohort. Now, the program is an entire 8 months program where you are going to be having 6 months in-class training, learning all the technical skills and employability skills also. And then when you're done with the 6 months training, you have another 2 months of internship with another company that we partner with. So 6 months in-class training, 2 months of internship, which makes up an entire 8 months program. And the entire 8 months program costs $900 US. Okay. I think for all of the benefits that I've made mention of earlier, right, I think it's definitely worth $900 US. But for those of us that have waited on this call up until this time, right, this is where I get to give you that freebie that I was saying earlier. So for everyone on this call at this present moment, right, we have just over 23 people left on this call. So we are handling a discount to the first 20 people to register for the program. And the discounted amount will you pay $750 instead of $900. Okay, so you'll be paying $750 for the discounted amount, right? And the payment structure is very flexible. So you can pay, in installments. You don't have to pay everything at once. So you can pay up to 5 month installments where you're paying as low as $150 every month for the next 5 months. That is how you can set up that's how you can actually that is how you can lock in your spots for the discounts. Okay. So you can pay in installments where you can pay as low as $150 for the next 5 months. Okay. So I'm going to be walking us very quickly as to how we can go ahead and make this payment. Okay. Now the discount is for the first 200 people. Once we have the first 200 people, the discount goes away and the price reverts back to the original $900. Okay. So now how can we make our payments? How can we get on the program as soon as possible? So I'm going to be showing us how we can do that. So my colleague is going to be passing a link in the chat right now. The link is going to bring you to this enrollment center where you can make your payments. Okay. So 1 second while this particular website loads. So you're going to get in the link in the chat that's going to bring you to this enrollment center. Let's assume you want to go ahead and pay for the data science program. All you want to do is scroll all the way down. You'll see where it says the full stack data scientist. Full stack data scientist right here. So all you want to do is go ahead and click on register for FSDS. Just click on that. Then it's going to bring you to where you can make payments. All right. Okay, now, so let's assume you want to be very flexible with your payments. All right. You want to go ahead and pay 5 times. So all you have to do is come down here, click on 5 monthly payments, click on secure your seats, then proceed. So you can then go ahead, put in your information here and pay for products. Now, this is the most important part of payment. Once you are done paying, all right, you want to go ahead and go into your email. There will be a receipt that has been sent into your email. So go into your inbox, take a screenshot of that receipt, all right, and then come back to this landing page right here. Okay, scroll all the way to the middle. You see where it says upload your receipts here. Click on this, and then you can go ahead and upload that screenshotted receipt. Now, once you're done uploading that, we will confirm the payment on our side, and we will have a team member reach out to you, send you your welcome toolkit and a link to onboard you for the program starting on the 5th of July. So that is how you can get started with Tenalytics. That's how you can lock in on the discounts, and you can be well on your way to becoming a full stack data scientist. Okay. So right now I'm going to be taking questions. So if you have any question, right, do well to ask your question, drop it in the chat, and I'll be giving us all the clarity that we need. All right. So you have any questions, you can go ahead and drop your questions in the chat, and I'll be giving us the clarity that we need. So like I was saying earlier, there is a form that is being passed in the chat. Okay, so it's an attendance form. Filling this form is going to give you access to all of the materials that was used during this session. So the slides, right, and all of the links to the data sets that was used to train the model, right? And the recording of, from when Akuna was walking us through the machine learning training program and all of that, you'll be getting all the recordings if and only if you fill the attendance form that is being passed in the chat. Okay? So if you have any question, do well to drop a question in the chat. I'll be giving the clarity to all our questions in a bit. So any questions? Any questions? If you have any questions as regarding, the program structure, the fees, the payment structure, whatever question you have, you can go ahead and drop it in the chat, and I'll be doing my best to give you clarity before we bring this session to a close. So if you have any question, go ahead and drop it in the chat, and I'll do my best to give you all the clarity that you need. So Comfy is saying she dropped the question. So are the classes pre-recorded? If yes, how do I get answers to my questions when I have one? So Comfy, the classes are not, so it's a blend of live classes and self-paced videos. Okay, so this is the way the classes are structured. You're going to be having your live classes on Saturdays. Okay, Saturdays, 11 a.m. to 2 p.m. West African time for those in the European time zone. All right, so that happens on Saturdays, right? And you have live classes twice in a month. So 2 Saturdays in a month for your live classes, right? The other Saturdays, they are for your self-paced videos. So your instructor are going to be pre-recording some, videos and sending them to your LMS for you to watch and learn at your own pace. Okay? So now, during the week, on Wednesdays specifically, we have what we call the drop-in session. Okay? Now, during the drop-in session, you get to be able to come into the class and ask every question that you need clarity to. So if there's a concept that is being taught in class you do not understand, you can get to share your screen and walk your instructor through all of that. So you have instructor access 247. Okay, so you have dedicated instructors 247. Matter of fact, when you join the program, you will be placed in a virtual community hosted on WhatsApp. All right, so this community, you have access to your instructors, to your peers, and everything like that, right? So you are going to be in the know as to everything that you need clarity on, okay? So that is the way the classes are structured. I hope this answers your question. Comfy? So if we have any other questions, let's go ahead and drop the question in the chat. All right, Comfy, you're welcome. So if you have a question, let's go ahead and drop it in the chat and we'll get clarity to our questions before we round up this session. So we're about to wrap up. Just in less than 5 minutes, we are going to be done. So if you have any question, and like I said, the payment for the discount is just for the first 20 people. So you want to hurry now. The link is in the chat, right? Just go ahead and grab a link, put it in your browser so that you can make payments. Yeah, so Comfy, once you fill in the attendance form, we would be able to reach out to you. Okay, so there's an attendance form that is in the chat. All you have to do is fill in that form, Comfy, and then we'll be able to reach out to you. You're welcome. All right, so I'm just waiting for any other questions before we call this a day. So any other question before we bring this session to a close? So I think we are good. There are no other questions. All right then. So thank you everyone for joining this session. It was, it was exciting to be here to handle the session, and I can't wait to see us resume for the 5th of July cohort. Okay, so please do fill in the attendance form in the chat to get access to the recording of the program and also to the materials that are used for this program. And then grab the payment link and make your payment as soon as you can so that you can get access to that discount and start your tech journey with us for the 5th of July. Thank you, everyone. Cheers and bye for now.